MultiD, a foundational database of 1.8 billion small molecule conformers towards a universal conformational model, Elegant Mathematics presents. The Elegant Mathematics team presents MultiD and its core database HugeMDB, which already contains 1.8 billion conformers of small molecules. We began building this database in 2017, launched it in 2020, and continue to expand it. Our long-term goal is to build a foundational model for all conformers of small molecules. Our motivation is first, instant molecular docking, second, fast search in mass spec and NMR data, and third, accelerating drug discovery. Traditionally, there were only a few options. First, molecular mechanics, a spring-based model for bonds, angles, torsions, and van der Waals interactions. A modern PC finds a few local minima in minutes. Second one, semi-empirical quantum mechanics, sometimes more accurate, but may take up to a full day per molecule. And the last one, experiment, for example, X-ray diffraction, which is not always available. But for real-time chemical analysis, such as mass spectrometry, we must evaluate hundreds or thousands of molecules per second. For docking, millions of candidate molecules. So we needed a different, more elegant approach. We chose an innovative route, almost molecular mechanics, but with one crucial twist. For each atom, we determine a unique local environment, all atoms within covalent distance not excluded by others. We call this the atom index. Example, in ethene and toluene these indices differ, while in the benzene ring of toluene there are pairs of atoms with identical indices. With our atom index, all interactions depend only on distances. Torsions and valence angles disappear. Thus, for each atom pair in a molecule, there are only three interaction types. First, bonded interaction. Second, short-distance interaction when both atoms share a common neighboring atom. And all other interactions. These interaction types are determined by the pair of atom indices, and in the short-distance case, also by the index of the third atom. We have first atom indices around 8,000 for organic molecules and around 1 million for all possible molecules. And second, we have interaction type parameters, billions in principle, but after classification only a few million remain. We obtain our own molecular mechanical field, where parameters A, B, P, W are uniquely defined by interaction type. The indices play the role of the first neural layer, and the interaction types from the second layer with parameters. This looks like standard molecular mechanics, but only almost. Yes, one can write the gradients, use quasi-Newton and minimize, but we want a simpler, more elegant formulation. Most of the minimization over E can be written analytically. Van der Waals terms are handled via physically informed neural networks or compressed sensing. Thus, knowing which blocks, radicals, and atoms from a molecule, we can immediately determine which molecules can be assembled from them and which major 3D conformers they have. As a bonus, we obtain a robust consistency check system using our molecular achievements before the hackathon. In 2017, from 1 million graphs, we trained the parameters and then predicted 10 million PubChem molecules with high accuracy. In 2020, from 10 million graphs, we generated 200 million conformers and refined both the indices and the parameters. In total, today we have 1.7 billion reliable conformers, with 20% validated against PubChem showing excellent agreement. We support coordination compounds, fuzzy bonding rules, and arbitrary chemistry. One example application is fast search for magnetic materials. Achievements during Evolved Technology Hackathon 2025. We practically verified that our model parameters are stable and have precision. Switching from single to half precision gives a dramatic speed up. Using all 8 units NVIDIA H100 GPUs, we expanded the current database by an additional 150 million conformers. The MultiD database is open today for search and downloading. You're welcome to explore it at multid.com. Our next goal is to build a full foundational model capable of producing all configurations and all major conformers of a molecule from a list of radicals in real time. We thank the organizers of Evolved Technology Hackathon 2025 for running this event and for providing 8 units of NVIDIA H100 compute access. Thank you very much.